Welcome to the Firewall Filters Framework and Functionality module. By the end of this module, you should be able to describe the functionality and the framework of firewall filters. Other vendors often refer firewall filters to as Access Control Lists, or ACLs. The Junos firewall filters are stateless, and the software primarily uses them to control traffic passing through a Junos device. Stateless firewall filters examine each packet individually. Thus, unlike a stateful firewall that tracks connections and permits you to specify an action to take on all packets within a flow, a stateless firewall filter does not detect connections. The stateless nature of these filters can affect the way you write the firewall filters. Because the system does not keep state information about connections, you must explicitly allow traffic in both directions for each connection that you want to permit. Stateful firewall filters only require you to permit the initial connection, and then automatically permit bidirectional communications for this connection. You can use firewall filters to restrict certain types of traffic from passing into and out of your network. You can also use firewall filters to perform monitoring tasks that help you plan an effective security strategy for your environment. Although routing policies and firewall filters serve different purposes and have different match and action conditions, they both have a common structure. As with routing policy, the fundamental building block of a firewall filter is the term. A firewall filter consists of one or more terms. The software evaluates the terms sequentially until it reaches a terminating action. A term contains 0 or more match conditions and 1 or more actions. The from statements in the conditions describe match conditions, and the then statements describe the actions to be taken if a match with the from statement occurs. If all the match conditions are true, Junos OS takes the specified action within the term. If no match conditions are specified, all traffic matches the firewall filter term and is subjected to the stated action. You use a filter to group multiple terms and establish the order in which the system evaluates the terms. The Junos firewall filters require at least one term. Firewall filters always include an invisible default term that discards all packets that the configuration does not explicitly permit through the defined terms. The default action is inbuilt. You cannot configure or disable it. Note that when implementing firewall filters, keep in mind that the order of the terms is important and can affect the results. If you must reorder terms within a filter, consider using the insert CLI command. You can specify the criteria to use for matching packets in from clauses within firewall filter terms. You can use many header fields as match criteria. However, remember that all header fields may not be available to you because of the way firewall filters are processed. When you specify a header field, Junos OS searches for a match at the location in the header where that field should exist. However, it does not verify to ensure that the header field makes sense in the given context. For example, if you specify that the software should search for the ACK flag in the TCP header, the software examines for that bit to be set at the appropriate location, but it does not verify that the packet is actually a TCP packet. Therefore, you must account for how the software examines for a match when writing filters. Here, you would have the system check that the packet was a TCP packet and whether the TCP ACK flag was set. The stateless nature of firewall filters can affect the information available in the processing of fragmented packets. Processing fragments are more complicated with stateless firewall filters than with a stateful firewall filter. The first fragment should have all the layer 4 headers, but subsequent fragments do not. Additionally, attempting to check layer 4 headers and fragments produces unpredictable results. Junos OS still attempts to evaluate the layer 4 headers, but the second and subsequent fragments do not contain these headers, so the matches are unpredictable. Match conditions fall into 3 categories: numeric range, address, and bit field match conditions. You can generally use the same evaluation options for each condition within the category. Several text synonyms exist that function as match conditions. A text synonym match condition is equivalent to one or more match conditions. For example, the TCP established match condition is a text synonym for the TCP flag ACK or the TCP flag RST match conditions. You can specify actions in the then clause of a term. Common firewall filter actions include terminating actions, flow control, and action modifiers. Terminating actions cause the evaluation of the firewall filter to stop. The accept action causes the system to accept the packet and continue the input or output processing of the packet. The discard action causes the system to discard the packet silently, without sending an Internet Control Message Protocol or ICMP message to the source address. The reject action causes the system to discard the packet and send a message back to the source address. The default message sent by the system is an ICMP message with a destination unreachable message type and administratively prohibited message code. You can use an optional argument with the reject action to cause the system to send an ICMP message with a different message code, or to cause it to send a TCP reset instead of an ICMP message. If you specify the TCP reset option, the system responds to TCP packets with a TCP reset, but it sends no message in response to non-TCP packets. Other common firewall filter actions affect the flow of policy evaluation. The next term action causes Junos OS to evaluate the next term. The next term action is useful if you want to set a policer or a diffserv code point or DSCP value and still have the traffic evaluated by the rest of the filter. The next filter action does not exist for firewall filters. You can specify one or more action modifiers with any terminating or flow control action. If you specify an action modifier, but do not specify a terminating action, the system implies an action of accept. You can use the count, log, and syslog action modifiers to record information about packets. The forwarding class and loss priority action modifiers are used to specify class of service or COS information. The policer action modifier provides you to invoke a traffic policer. Note that when you apply a firewall filter, the traffic that does not match a term that has an explicit or implicit accept action will be discarded, even if it does not match any term with a discard action. Sometimes the action specified in a term is not one of the terminating actions, accept, discard, or reject. In this case, the default behavior is that Junos applies an implicit accept action and filter evaluation terminates. In this filter, term 2 is never evaluated because term 1 always matches and accepts. If you want to apply an action modifier, such as count, log, syslog, forwarding class, loss priority to a packet, and then continue to evaluate terms to decide whether to accept, discard, or reject, you need to use the next term flow control action. In this filter, term 2 is always evaluated because term 1 contains the next term action. Welcome to the Firewall Filters Use Case module. By the end of this module, you should be able to implement firewall filters for a given use case. Implementing a firewall filter requires two distinct steps. The first step is to define the firewall filter. In Junos OS, you define firewall filters under the Edit Firewall hierarchy level. Because Junos OS supports multiple protocol families, you must navigate down to the appropriate family hierarchy level. This sample illustrates an IPv4 firewall filter defined under the Edit Firewall Family INET hierarchy level. If discard is not present, then packets are accepted. The software supports other protocol families. Note that each protocol family supports a different set of match conditions. Refer to the product-specific documentation for details. Although you can use firewall filters to filter traffic at several points, their primary purpose is to filter traffic entering or exiting interfaces. You can apply them to all interfaces. Additionally, you can apply them to the LO0 logical interfaces to filter traffic destined for the system. You can apply IPv4 firewall filters to interfaces in the Edit Interfaces interface name, unit, unit number, family, INET filter hierarchy. To apply a single input or output filter, use the Input, Filter Name, or Output, Filter Name configuration options. You can specify both input and output filters on the same interface. You cannot, however, apply an IPv6 firewall filter to an IPv4 interface. In other words, the protocol family for the firewall filter and the interface must match. You can also apply multiple filters to filter traffic using the input list or output list configuration options in the Edit Interfaces, Interface Name, Unit, Unit Number, Family INET filter hierarchy. Anytime you perform configuration changes from a remote location, use the Commit Confirmed option when activating a new configuration. This habit might prove to be especially helpful when working with firewall filters and might save you from a late-night trip back to the office. This diagram depicts how firewall filters are applied. Because the objective is to filter inbound HTTP traffic on the GE0/0/1.0 interface, you should apply the appropriate filter to the GE0/0/1.0 interface as an input filter. Based on this configuration, and specifically the Allow Web Traffic term, the software permits inbound HTTP traffic to address 172.27.102.100/32 only. Note that the Deny Other Web Traffic term specifically denies all other HTTP traffic. This denial is not strictly required because the default action for all traffic not explicitly permitted is discard. Transit firewall filters act on packets flowing from one interface to another interface within a device running Junos OS. These filters can protect sites from unauthorized access and other threats. But what about protecting the system from unauthorized management access and other harmful effects? This concern is the idea behind applying a firewall filter to protect the routing engine. The packet forwarding engine applies these filters before traffic ever reaches the control plane. The software does not create automatic holes in the LO0 firewall filter. Therefore, besides permitting management traffic, you must also permit routing protocol and other control traffic to reach the routing engine. The implicit silent discard, which discards all packets not explicitly permitted through a defined term, is known to cause undesirable effects. Consider the basic firewall filter named Limit SSH Access, which controls management access to the local system. The software applies the filter to the LO0 interface as an input filter and evaluates all incoming traffic destined to the routing engine. The Limit SSH Access filter includes three distinct terms. The first term, SSH Accept, permits all SSH traffic from a defined prefix list trusted. The trusted prefix list is displayed. A second term, SSH Reject, discards all other SSH traffic not sourced from the trusted prefix list. A third term permits all other traffic. Your firewall filters must account for all management and protocol traffic destined to the control plane. Here, this accounting is accomplished using the Else Except term. If the Else Except term is not included in the filter, the software discards all control and management traffic not specifically permitted in the other terms. This process can cause quite a disturbance in environments that use dynamic routing protocols, such as OSPF and BGP, as well as management protocols such as SNMP or Network Time Protocol or NTP. The objectives and topology for a firewall filter use case are outbound and inbound. Note that all filters are applied to the GE0/0/1.0 interface. The sample output filter used to meet part of the objectives is displayed. The sample input filter used to meet the rest of the objectives is displayed. This example shows the application of the firewall filters. Here are some common firewall commands used to monitor filters. In the configuration for this case study, the count and log action modifiers are used. Counters maintain a cumulative packet and byte count. Counters are specific to the filter, so the system keeps separate statistics for counters with identical names that exist in separate filters. By default, the system keeps only one set of statistics for each counter in a filter. So if the same filter applies to multiple interfaces, all matching packets from all interfaces with the filter applied increment the same counter. You can access counter statistics with the displayed commands. Note that you can reset counter statistics with the Clear Firewall Filter command. You can also specify an optional counter argument to reset the statistics for a single counter. You can configure the system on a per-filter basis to keep interface-specific statistics for counters. When you configure the system in this way, the system creates a new counter for every logical interface and traffic direction where the filter is applied. You can display the logged packets using the Show Firewall Log CLI command. A filter name or blank space appears if the routing engine handles the packet. Otherwise, a dash or PFE appears instead of the filter name to indicate that the packet was handled by the packet forwarding engine. The contents in the firewall log get cleared when the system reboots. Welcome to the Policing module. By the end of this module, you should be able to implement a policer within Junos OS. Besides dropping or accepting packets, firewall filters can also police or rate limit traffic. Rate policing enables you to limit the amount of traffic that passes into or out of an interface. Firewall filters that use rate policing still employ normal match conditions, such as addresses, protocols, ports, and so forth, to determine which traffic on an interface is subject to rate limiting. As usual, the lack of a from clause matches all packets that do not match an earlier firewall filter term. If the first term in a firewall filter lacks a from clause and contains a policer, all packets on the interface, input or output, as the filter is applied, are subject to rate policing. Junos OS also accommodates interface-based policers that you apply directly to a given protocol family on a given logical unit of a particular interface. Such policers accommodate Layer 2 VPN traffic as well as the MPLS and IPv6 families. And they operate without the need for a calling firewall filter. Actual policer support might vary between Junos devices. Refer to the documentation for the specific product for support information. Policing employs the token bucket algorithm, which enforces a limit on average bandwidth while enabling bursts up to a specified maximum value. You can configure two rate limits for the traffic: bandwidth, which is the number of bits per second permitted on average, and maximum burst size, which defines the total number of bytes the system permits in bursts of data that exceed the bandwidth limit. The preferred method for determining the maximum burst size is to multiply the speed of the interface by the amount of time bursts that you want to allow at that bandwidth level. For example, to permit bursts on a fast Ethernet link for 5 milliseconds, a reasonable value, use the calculation displayed. This calculation yields a burst size of 500,000 bits. You can divide this number by 8 to convert it to bytes, which gives you a burst size of 62,500 bytes. You can specify the bandwidth as a number of bits using the bandwidth limit statement. You can specify the maximum burst size as a number of bytes using the burst size limit statement. When a packet matches a term that has a policer in the then clause, the system first determines if the packet exceeds the policer. If the packet does not exceed the policer, the system performs the actions in the firewall filter's then clause, as if you left the policer out of the configuration. If the packet does exceed the policer, the system takes the actions in the policer's then clause. If the policer's then clause does not result in the software discarding the packet, the system takes the remainder of the actions in the firewall filter's then clause. Note that in cases where the specified rate limit has been exceeded and both the policer's then clause and the firewall filter's then clause define action modifiers, the system uses the policer's action modifiers. For example, this firewall filter polices all TCP traffic that exceeds 10 Mbps with a 62,500 byte burst size. It places traffic that exceeds these limits in the best effort forwarding class, whereas it places traffic that conforms to these limits in the assured forwarding class. In this example, you define a policer named P1 that discards traffic that exceeds the defined average bandwidth of 400 kilobits per second and the defined burst size limit of 100 kilobytes. Once you define this policer, you can call it from any firewall filter. By default, devices running Junos OS treat each invocation of the policer separately and track statistics separately for each term that references the policer. You can think of the policer definition as simply defining a set of parameters that you can choose to reference in any firewall filter term. The filter rate limit subnet polices traffic from the specified subnet. If the traffic source from the specified subnet exceeds the limits, the system discards it. If the traffic does not exceed the specified limits, the system accepts it. You can use the K, M, and G abbreviations to indicate 1,000, 1 million, and 1 billion bytes or bits, respectively. Welcome to the Unicast Rpf module. By the end of this module, you should be able to describe the operation and configuration of Unicast Rpf. The Unicast Reverse Path Forwarding, or RPF, automates anti-spoofing filters based on routing tables, also known as Routing Information Base, or RIB. These checks validate packet receipt or interfaces where Junos OS would expect to receive such traffic. By default, the system expects to receive traffic on a given interface if it has an active route to the packet's source address, and if it received the packet on the interface that is the next hop for the active route to the packet's source address. For example, if a device running Junos OS receives a packet with the source address of 10.10.10.10 on interface GE0/0/1.0, and you configure the device to perform the Unicast Rpf check on that interface, it examines its routing table for the best route to 10.10.10.10. If this route lookup returns a route for 10.10.10.0/24 with a next hop of GE0/0/1.0, the packet passes the Unicast Rpf check and is accepted. You can combine both Unicast Rpf and firewall filters on the same interface. Junos OS accomplishes Unicast Rpf checks by downloading additional information to the packet forwarding engine. Therefore, activating this feature increases packet forwarding engine memory usage. By default, devices running Junos OS use the strict mode RPF check. You can instead configure it to use the loose mode RPF check, which checks only to ensure a valid route to the source address exists in the routing table. However, in networks with the default route, a valid route to every IP address always exists. So, using a loose mode check does not make sense in this environment. In general, using the default strict mode provides the best results. By default, when a Junos device performs its RPF check, it considers only the active routes to a given destination. In networks where perfectly symmetric routing exists, the default behavior of considering only active routes should work. However, in cases where the possibility of asymmetric routing or different forward and reverse paths exists, this design can cause legitimate traffic to be dropped. To ease this issue, you can require that the system consider all feasible routes to a destination when it performs the RPF check. In this mode, the system considers all routes it receives to a given prefix, even if they are not the active route to the destination. In networks where the possibility of asymmetric routing exists, you should activate this option. You do not need to implement RPF checking on all devices within your network. Typically, you configure only the edge device to perform RPF checking because all inbound and outbound spoofing passes through that device. In the sample network shown, R1 should be configured to perform RPF checks on all three interfaces. Note that the Unicast Rpf configuration options vary between Junos devices. Refer to the product-specific documentation for detailed support information. When a device running Junos OS finds that a packet has failed the Rpf check, it discards it by default. However, if you specify an optional fail filter, the device processes packets that fail the Rpf check through that filter prior to discarding them. In the fail filter, you can perform all the actions and action modifiers that you could in any other firewall filter, including accepting the traffic despite the packet failing the Rpf check. Note that if you choose to log packets in an input firewall filter, but the packets then fail the Rpf check, the software does not log them. To log these packets, you must log them in an Rpf fail filter. On most devices running Junos OS, Dynamic Host Configuration Protocol, or DHCP, and Bootstrap Protocol, or BootP requests fail the Rpf checks. To enable these requests, you must configure a fail filter that permits traffic with a source address of default and a destination address of 255.255.255.255. This code shows a sample fail filter to include DHCP and BootP requests. In the example, Rpf is enabled in strict mode on GE0/0/1, and a Junos device considers only the active paths to any prefix. If Rpf is enabled in loose mode on GE0/0/2, a Junos device considers a valid route to the source address in the routing table. The fail filter named Rpf DHCP applies to the GE0/0/3 interfaces. As you can see, the configuration defines the Rpf DHCP fail filter and permits DHCP and BootP requests. Now that you have enabled Rpf on all interfaces, you do not need to include anti-spoofing terms within the firewall filters. Use Show Interfaces, interface name commands with either the extensive or detail options to verify that Unicast Rpf is enabled and working on Junos device. The flags, output field near the bottom of the display reports the Unicast Rpf status. If Unicast Rpf has not been enabled, the URPF flag is not displayed.